Scalar triple product, that is A dot B cross C, whenever equal to 0, it is said to be as coplanar vectors. If two rows are same, then the scalar triple product will be equal to 0. AB vector, box product of AC and then AD equal to 0. PQ cap is given by PQ vector divided by magnitude of PQ vector. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learned many problems on the product of, that means the vector product of an algebra, isn't it? Now, in this session, we are going to have a scalar triple product, dear students, and this is your last session of your chapter number 10, vector algebra. Then without any delay, let us start. What do you mean by the scalar triple product? And based on that, the problems. Now here, A vector, B vector and C vector are any three vectors, then this is very important. We are going to call it as box product. So this is called as a box product or scalar triple product, which is nothing but this one. Scalar triple product of three vector is denoted as like this. A vector, which is nothing but A vector, B vector, C vector, can also be written as A vector dot B cross C. That's it. So this is going to be known as the scalar triple product. Now, what is A vector, ma'am? The coefficient of A vector will be like this. A1i plus A2j plus A3k. Similarly, B vector is nothing but B1i plus B2j plus B3k. And C vector will be is equals to C1i plus C2j plus C3k. So how we are going to solve this one? Scalar triple product, which will be equals to, you are going to expand the determinant by writing the coefficients of A vector, B vector and then C vector, which is A vector is nothing but A1, A2, A3. B vector is B1, B2, B3, coefficient of I, J, K and coefficient of I, J, K of C vector, which is C1, C2 and C3. You are going to expand this one and finding the value. So that itself what is called as a scalar triple product or a box product. Now here, if scalar triple product, that is A dot B cross C, whenever equal to 0, it is said to be as coplanar vectors. What it is said to be? It is said to be as coplanar vectors. And you are going to use this scalar triple product to find out the value of the volume of a parallelepiped. Okay. So these are all the things are very important for a box product or scalar triple product. Now, so knowing these conditions, we'll be moving on to solving the problems on those. Now here they have given find the scalar triple product of the vectors. A vector is equals to I plus 2j minus 2k and then B vector is equals to 3i plus 2j plus 2k and C vector is equals to 2i minus j plus k. Now you already know scalar triple product is denoted by box product of ABC, or you are going to write it as A vector dot B cross C. So which is given by, you can have coefficient of A vector which is 1, 2 and minus 2 and B vector coefficient is something but 3, 2 and 2 and C vector is nothing but 2, minus 1 and 1. Just you are going to expand this by having here plus, minus and then plus. So what happens? 1 into, you are going to leave the first column, first row. 2 into 1 is 2, minus of minus is nothing but plus, 1 into 2 is 2. Similarly, minus 2 into, you are going to leave the second column and the first row. 3 into 1 is 3, minus 2 2s are 4, again plus you're going to take minus 2, plus into minus is minus. If you want, you can write it later. Now here, leaving the third column in the first row, 3 into minus 1 is minus 3, and then minus 2 2s are 4. Correct? Now you can simplify still further. 2 plus 2 is nothing but 4. 4 into 1 is 4. Correct? Again, 3 minus 4 is minus 1. Minus 1 into minus 2 is plus 2. Similarly, here plus into minus is minus, but be careful, here minus 3 minus 4 is minus 7. Minus 7 into minus 2 is nothing but plus 14. So, plus 14. So, the answer you are going to get it as 14 plus 4 is 18. 18 plus 2 is nothing but 20. So, that is what the scalar triple product of the given vectors A, B and C. That's it. Now, we'll be moving on to the next problem. Now, here they have given evaluate I minus j plus k, 2i plus j plus k, 2i plus j plus 2k. Here they have given a box product. So, we are going to take it as, so given vector is nothing but you can take it as A vector, B vector, C vector can be written as, which implies that coefficient of this A vector 1, minus 1 and 1. Correct? And then 2, 1 and 1. And then 2, 1 and 2. 2, 1 and 2. Expand this ds. So here plus, minus and then plus. So 1 into, leaving the first column first row, 1 into 2 is 2. Minus 1 into 1 is 1. Again minus, see already minus is there. Minus of minus it will become plus 1 into, leaving the second column first row, 2 into 2 is 4. Minus 2 into 1 is 2. Again plus 1 into, you are going to have, leaving the third column first row, 2 into 1 is 2. Again minus 2 into 1 is 2. Further simplifying this, 2 minus 1 is 1. 1 into 1 is 1. 4 minus 2 is 2. 2 into 1 is 2. Again 2 minus 2, this will become 0. So the answer you are going to get it as here 3. That's it. This is the value you are going to have, dears. How easier to solve the scalar triple product or box product, isn't it? Now we'll be moving on to the next problem, dears. What they've asked. Find the volume of the parallelepiped whose coterminous edges are 2i plus j plus 3k minus I plus 2i plus k and then 3i plus j plus 2k. So coterminous edges means they have given A vector, B vector and C vector. So take it in the box product of A vector, B vector, C vector, which is nothing but coefficient of 2, A vector 2, 1 and 3. 2, 1 and 3 and then minus 1, 2 and then 1, this one and then 3, 1 and 2. Expanding this, now plus, minus and plus, so 2 into, leaving the first column first row, 2 2s are 4, minus 1 into 1 is 1, correct? Again minus 1 into, leaving the second column first row, minus 1 into 2 is minus 2, again minus 3 into 1 is 3. Similarly, plus 3 into, leaving the third column first row, minus 1 into 1 is minus 1. Again, 3 into 2 is minus 6. So, therefore, you are getting here by after evaluating, 4 minus 1 is 3, 3 2s are 6. Minus 2 minus 3 is nothing but minus 5. Minus 5 into minus 1 is plus 5. Again, minus 1 minus 6 is minus 7. Minus 7 into plus 3 is minus 21. So, minus 21. So, therefore, you are having 6 plus 5 is nothing but 11. Minus 21 gives you the value minus 10. So, if it is minus 10 means the value it will be a decreasing. That's it. So, the volume of the parallelepiped will be is equals to minus 10. That's it. Now, we'll be moving on to the next problem. Show that the vectors A vector, B vector, they have given I minus 2j plus 3k, B vector is minus 2i plus 3j minus 4k, and then C vector is I minus 3j plus 5k are coplanar. What is the coplanarity condition, dears? The coplanarity condition is nothing but if A dot B cross C equal to 0, then A vector, B vector, C vector are said to be coplanar, isn't it? Now, we'll be moving on to solving now A vector dot B cross C. So, A vector dot B cross C is nothing but coefficient of A vector 1, minus 2 and 3. Observe dear students what I am writing. And B vector is minus 2, 3 and minus 4. And then C vector is nothing but 1, minus 3 and 5. Minus 3 and then 5. Now expanding this one, you are going to get it as 1 into, leaving the first row and first column, 3 5s are 15. Minus of, here minus 3 into minus 4 is plus only, but here 1 minus in the sign is there. Plus into minus is minus. So 4 3s are, you are going to have 12. Next, minus of minus, because here plus, minus and then plus. Minus of minus is plus 2. Leaving the second column, first row, minus 2 into 5 is minus 10. Again, minus already is there. Another minus will come here, which will be plus. 4 into 1 is 4. Again, plus 3 into, you are having, leaving the third column and the first row, minus 2 into minus 3 is nothing but plus 6. Again, minus 1 into 3 is 3. Now let us evaluate this further. You are going to get 15 minus 12, which is 3. 3 into 1 is 3 only. Again, minus 10 plus 4 is minus 6. Minus 6 into plus 2 is minus 12. Now 6 minus 3 is 3 itself. 3 3s are 9. So plus 9. Now you can have here 9 plus 3 is nothing but 12. 12 minus 12, you are going to get it as, which will be is equals to 0. Therefore, if A vector dot B cross C equals to 0, then the A vector, B vector and C vector are said to be coplanar. Therefore, A vector dot B cross C equals to 0, then A vector, B vector, C vector are said to be coplanar. That's it. I hope you understood this problem. Now we'll be moving on to the next one. Prove that A vector plus B vector, comma, B vector plus C vector, comma, C vector plus A vector equals to 2 times of the box product of A vector, B vector and then C vector. Dears, think this one as a vector. Think this whole as a B vector, think this whole as a C vector. So you need to take it as A dot B cross C. In place of A, you are going to write it as A vector plus B vector. In place of B vector, you are going to write it as B vector plus C vector. In place of C vector, you are going to write it as C vector plus A vector. I hope you got this one. Now therefore, A dot B cross C. Yes, you are getting, I know. Now, multiplying the bracket first. This, let me keep it next. A vector plus B vector dot. Now, B cross C. So, B vector cross C vector. Again, plus B vector cross A vector plus, now, along with C. C vector cross C vector. C vector cross C vector plus C vector cross A vector, C vector cross A vector, vector cross A vector. Now, you can have, you know that C vector cross C vector gives you 0. So, therefore, you can have A vector, see, multiply this along with this, A vector plus B vector dot B vector cross C vector. So, B vector cross C vector plus B vector cross A vector plus C vector cross A vector, because C vector cross C vector gives you the value 0. Now you can have the dot product of this A vector dot B vector cross C vector, again plus A vector dot B vector cross A vector, again A vector plus A vector dot C vector cross A vector. Multiplying this A vector along with this and this one. Similarly, multiplying the B vector along all three. So, you are going to get it as plus B vector cross B vector cross C vector, again plus B vector into B vector cross A vector, again plus B vector into C vector cross A vector. Now, what and all it will be a 0? You know already A vector dot B cross A vector, because the two rows are same. Here, why two rows are same? Here also A1, A2, A3. See, A1, A2, A3 like this. A1, A2, A3. Similarly, B1, B2, B3. Now, in place of C1, C2, C3, again A1, A2, A3. If two rows are same, then the scalar triple product will be equal to 0. So, here two rows are same. So, this will be equals to 0 there. So, therefore, by writing that, see A dot B cross A, similarly here, A and A. So, two rows are same, therefore it is also 0. So, therefore, writing which implies that A dot B cross C plus 0 plus 0. Again, here also, this is also 0 plus 0. Be careful, two rows are same. First row and second row, B1, B2, B3, B1, B2, B3, C1, C2, C3. So, this is also 0. I hope you got. Now, this is also B1, B2, B3, B1, B2, B3. Two rows are same. Therefore, this is also 0 plus remaining is B dot C cross A. Whatever you write, B dot C cross A or A dot A cross B or C dot A cross B, that is what the scalar triple product of ABC, just expanding. So, therefore, you can have which implies A dot B cross C plus that also A dot B cross C. So, which is nothing but 2 times of A dot B cross C, which can be written as ABC of the scalar triple product, which is a RHS. That is your right hand side. Now, by taking the left hand side, we have proved the right hand side, which is nothing but the left hand side will be equals to the right hand side. I hope you understood this one. Now, we'll be moving on to the next one. Prove that A vector, comma, B vector, comma, C vector plus D vector. In place of C, you are having C plus D is equals to A vector plus B vector, box product of ABC and then box product of ABD. Let us take the left hand side. Left hand side, writing that A dot B cross C. Okay. Now, expanding this one, which implies that A. Now, first let us write inner side B cross C, B vector cross C vector plus B vector cross D vector. Now, let us do the dot product with each. Now, what happens, which implies A vector dot B cross C plus A vector dot B cross D. If A vector dot B cross C is box product of ABC, what is A vector dot B cross D? Box product of ABD, that's it. Therefore, which implies that box product of ABC plus box product of ABD, that's it. And this is your RHS. I hope you understood this problem also. Now, we'll be moving on to the next one. Find X such that the points, which are all the 4 points, A of 3, 2, 1, B of 4, X 5 and C of 4, 2, minus 2 and D of 6, 5, minus 1 are coplanar. Now, here, now they have given the 4 points A, B, C, D. We need to find out the position vectors. Now, position vectors is nothing but AB vector, correct? So, AB vector is nothing but OB vector minus OA vector. OB is nothing but this one, 4, X and 5. And OA is 3I, 2I plus 1I. 4I plus XJ plus 5K. Okay. Now, minusing that, which will be giving you 4 minus 3 is nothing but I, 1I. Again, X minus 2 into J plus X minus 2 into J. Again, 5 minus 1. 5 minus 1 is nothing but 4K. Now you are having A, B, C, D. We have found out now AB vector. If AB, AC and ED, the box product equal to 0, you are going to take it as, because they have given it as coplanar. So here I am putting a condition, AB vector, box product of AC and then AD equal to 0. Now let us find out AC because we have already found out AB. So AC vector is equals to OC vector minus OA vector. OC is nothing but coefficient of C, which is 4, 2 and minus 2, which will shall minus 4 minus 3 is 1I. Again 2 minus 2 is 0J. Again minus 2 minus 1 is minus 3K. Okay, next AD vector. AD vector is nothing but OD minus OA. So which implies that now D is nothing but here 6 minus 3, which is nothing but 3I. Again 5 minus 2, which is 3J. Next minus 1, which is minus 2K. Now let us take the box product of this here. So here I have taken already, which will be box product of coefficient of AB, which is 1x minus 2, 1x minus 2 and then 4. Next you are going to get it as 1, 0 and minus 3, 1, 0 and minus 3. Next is nothing but 3, 3 minus 2, 3, 3 minus 2. So here, let me take it as a expanding. So 1 into, which implies you are going to equate it to 0. 1 into 0 into minus 2 is 0. Minus of minus is plus 3, 3s are 9. Again, minus x minus 2 into, you are having, leaving the second column and the first row. 1 into minus 2 is minus 2. 3 3s are 9 plus 9 because already minus 3 is there. So again plus 4 into, leaving the third column first row, 1 into 3 is 3 minus 0, 3 zeros are 0. Now let us expand this one, what you are going to get it has. So if I expand that one, 1 into 0 plus 9 is 9, 9 ones are 9. Again minus of x minus 2 into minus 2 plus 9 is nothing but 7, 7. Again, plus 4 3s are 12 equal to 0. Let us take this one 9. 9. You are having minus 7x. Minus 7x. Minus into minus is plus. 7 2s are. You are going to get it as 14 plus 12 equals to 0. Now, you are having 14 plus 12 is nothing but 26. 26 plus 9 is nothing but 35, isn't it? So therefore, plus 35 minus 7x equals to 0, or you are going to take 7x to the right hand side. You are getting 7x is equals to 35, or x will be is equals to 7 ones are 7 5s are. The value will be equals to 5. I hope you understood this problem also of finding the value of x when the coplanarity condition by making the position vectors of the given 4 points. Okay, we'll be moving on to the next one. Evaluate 3a vector minus 5b vector dot 2a vector plus 7b vector. Now, let us know what is that? You are going to do the dot product 3a into 2b. So, let me take that one 3a dot 2a. Next, 3a plus, because plus into plus is plus, 3a vector dot 7b vector. Now, along with the b, minus into plus is minus, minus 5a b vector into 2a vector. Again, plus into minus is minus, 5b vector into 7b vector. Now, you know, b vector dot b vector is nothing but magnitude of b squared. So, here this is a vector dot a vector is magnitude of a squared, which implies that 3 2s are 6 magnitude of a squared plus here 3 7s are 21 a vector dot b vector. Again, 5 2s are, which you are going to take it as 10 minus 10 a vector dot b vector. Why I am writing a vector dot b vector? Because they are commutative. B vector dot a vector can be written as a vector dot b vector. So, minus 5 7s are, which is nothing but 35. B vector into b vector is nothing but magnitude of b vector squared. Now, you can evaluate this one. 6 magnitude of a vector squared to 21 times of a vector dot b vector minus 10 times of a vector dot b vector is plus 11 times of a vector dot b vector minus 35 magnitude of b vector squared. And this is your final answer you are going to get when you are going to evaluate the dot product of the given vectors. So, okay dear students, I hope you enjoyed all my session of the chapter Vector Algebra. So, until the next class, keep watching dear students. Thank you. Have a nice day.